This is Hacker Public Radio episode 3279 for Thursday the 25th of February 2021. Today's show is entitled Linux Inlaws S01E24, Legacy Programming Languages and is part of the series Linux Inlaws. It is hosted by Monochrome and is about 54 minutes long and carries an explicit flag. The summary is, the two chaps discuss why history keeps repeating itself in programming languages and beyond.
This episode of HPR is brought to you by archive.org. Support universal access to all knowledge by heading over to archive.org/donate.
This is Linux Inlaws, a podcast on topics around free and open source software, any associated contraband, communism, the revolution in general, and whatever else fancies your tickle. Please note that this and other episodes may contain strong language, offensive humor, and other certainly not politically correct language. You have been warned. Our parents insisted on this disclaimer. Happy, Mum? Thus, the content is not suitable for consumption in the workplace, especially when played back on a speaker in an open plan office or similar environments. Any minors under the age of 35, or any pets, including fluffy little killer bunnies, your trusted guide dog, unless on speed, and cute T-Rexes or other associated dinosaurs. Hi, Martin. How are things?
Hey, Chris. How are things? Things are great and wonderful.
Excellent. Today's this episode is all about Martin, upon the special request of a sole co-host.
Who?
Yes, Martin.
Hang on a minute.
Yes.
Is there another co-host? What's going on here?
No, Martin, this would be you.
Okay, so
You put this in, yes.
Yes, I remember now. Wow. Yes, brilliant programming languages and their mediocre modern counterparts.
The official title of the show actually was something more like Legacy Programming Languages, but that's okay.
It is. There you go. So, what are you going to cover tonight, Chris?
Well, let's talk about legacy programming languages and how they affect modern hipster languages.
Okay.
Like C, maybe Pascal, maybe Modular 2 or something.
Well, you got to define what's a legacy language in that case.
Anything until you were born, I suppose. That makes it mid-60s. No?
I don't think that counts. Yeah. So,
In that case, you define legacy and we go by it. That's okay.
No, but I mean, you can't say it's legacy because it's still being used. Legacy would be something that's no longer used and obsolete.
Well, that's true, actually, yes.
Well, maybe.
But some of the programming languages that we're going to cover only live in certain isolated biotopes, right? Biotopes, is that the word I'm looking for?
Well, it's generally
ecosystems.
Yeah.
Ecosystems is probably. So, for example, COBOL, never mind ALGO, we're going to cover that in a minute.
I'm not covering COBOL, by the way.
I am, but don't worry about this. I mean, you'll be hard pressed or hard pushed to find any application written in COBOL running not running on a mainframe.
Indeed. However, these applications have been running there for many, many years, very successfully, stably, and happily, right? So,
absolutely.
So could you
Because
call it a legacy language in that case?
absolutely, because the people who wrote them are long dead. and you'll be hard pushed to find anybody who can maintain the code. Just take a look at any general ledger on running on a mainframe driving your ordinary bank, right?
Mm-hmm.
People do a lot in order not to touch the code base. Any new functionality is normally implemented in systems surrounding these general ledgers because the general ledgers have been implemented were implemented about 30 years ago, 40 years ago. Solid code base has been tested to death. You do not want to change a running system.
So if don't change, so why would you?
Exactly. So if you need new functionality, you basically put a system in front of it, and then this new system does what you would normally incorporate in general ledger. No.
No, the systems around it are more to enable like your personal banking apps and that kind of nonsense, right? So it's not actually changing the ledger itself. So yeah, so you're saying COBOL is a legacy language? Yes.
Say again, sorry, what was that?
You are saying COBOL is a legacy language?
Oh, absolutely.
For which, and how do you define this legacy language?
As I said, legacy language, for the purpose of this podcast episode, is probably anything that was invented before the 70s.
Aha. So are we saying that computers are also legacy?
Well, yes, I suppose.
Oh dear.
Why?
Well, that's probably a lot of people that would not agree with that statement. But anyway, it doesn't matter. It's just a matter of definition. So for tonight's episode, anything legacy is anything your age and older.
Thank you, Martin. Yes. For the purpose of discussion, let's assume that, yes.
Okay, excellent. All right, then. So
Martin is going to cover Algo, I'm going to cover COBOL, and that will be the shortest Linux Inlaws episode ever, because essentially we're done after that.
Well, we could talk about programming language in general as well. But,
yes, we could.
We did a comparison one earlier. Okay,
so let's start actually with plan calcul.
How about
which is, right? Plan calcul.
Why don't we start with the beginning?
I'm just doing this. Plan calcul was actually a programming language that a certain Konrad Zuse invented, and that ran on something called a Z3.
Well, so this programming language would level the playing field, or whatever you want to call it, from assembler, right?
Invented in the, I think, early 40s, late 30s or something, when Zuse was just putting together Z3, essentially a collection of tubes held together by wire. Most people consider that to be the first iteration of something called what is known as now as a computer.
I think you'll find there were predecessors to that.
True. I'm
probably
talking about machines now. As a machines driven by electricity, not some other stuff.
Okay, fair enough. All right, so plan calcul.
So let's skip plan calcul.
Any experts out there?
No, Martin.
What were the
because these people would be now 80 years old or something, I don't know.
What were the
maybe 90
of this language? What were the characteristics of this language? Sure.
It ran on a Z3.
Okay. Right. Okay.
Simple as that. Of course, you'll find the links in the show notes in case somebody wants to dig up a Z3 emulator and run plan calcul on it.
No, if that exists. Okay, cool.
Okay. Yes, before we leave plan calcul, actually, as I said, you will find the links in the show notes. Plan calcul goes back to something, I think it was called, bear with me, a lambda calculus. Invented in the 30s by, I think, Alonzo Church and Stephen Kleene. And essentially, it's what's it called? What's what I'm looking for? Pretty much like comparable or something to Prolog. It was a equation solver, more or less, that ran on a Z3.
Right, you mean a calculator?
Yes, Prolog is a little bit more than that. Prolog is a formal theory improver, I think, but we'll cover that in a minute if we don't fall asleep before.
Okay.
Okay, what came next? I reckon Fortran and COBOL are pretty much alike, right? 50s.
Yeah, I think you're right.
And the idea at that stage was actually, I think both were developed by IBM initially. Fortran was taken over by some sort of committee, I think. NIST, ANSI, something like this. I can't remember. Links, of course, in the show notes. So if anybody wants to read up on this, you find the links in the show notes. The thing is that at the time, I think you had this notion of computers looking for a use case. So the machines at the time, and you're talking 50s here, not necessarily just ran by, just built on on a transistor basis, but rather still kind of working with cubes and stuff, or relays for that matter. We're doing simple calculations, and the idea behind COBOL and Fortran was actually to introduce an abstraction layer from assembler. So COBOL standing for Common Business Oriented Language, and Fortran, I think, for Formula Translator. The idea was to use something closer to something called the English language in order to implement algorithms rather than doing that in assembler. And the hint with COBOL is in the name. In contrast to Fortran, it was much more oriented at not necessarily mathematical equations, but rather batch processing, record transactions, and all the rest of it. Hence the name. Common business-oriented language, COBOL.
Good name. Yeah, Fortran obviously being more prevalent in the academic circles.
Funny enough, Fortran is still used today, even outside mainframe environments. Because if you take a look at some of the high-performance stuff that is still written in Fortran these days.
Like?
Some stuff in signal processing, for example, that you cannot do in C, or that you don't want to do in C. I can recall coming across some embedded systems where people, for some reason, chose Fortran over C.
Okay.
Probably has to do with floating point arithmetic or something like this. I don't know.
Yeah.
I mean, you still can get very performant Fortran compilers. The GNU, of course, has a front end. Links on the show notes. And most of the people consider GNU Fortran as one of the best Fortran compilers for Linux and other open source systems on the market at this point in time, I suppose. It's an outside the mainframe world.
What are these mainframes you keep talking about?
They go back to something called the early computers. I mean, 36 was invented mid-60s. And they are still an architecture that is still around. In contrast to all the PDPs 11 of the world, all the VAXs, they are gone. But mainframes, for some reason, have managed to linger on. I mean, IBM still makes a lot of money with selling something called System Z these days that has been around for the last 60 plus years, essentially, more or less. I mean, it comes in a different package these days and runs Linux and all the rest of it. But if you take a very hard cold close look, it's still that mainframe architecture that IBM invented in the 60s.
Mm-hmm. Yeah, I've stayed away from mainframes all my life.
But then you're one of these young hipster ones, right?
I'm an old hipster, let's put it that way.
Excellent. So Martin drinks coffee all day long, goes to fancy coffee places if they're open, if they're not. He can't go there.
No, I don't live in California.
And talks about Rust. What's it called? Julia, Kotlin, and all these other fancy languages.
Yeah. Scala, yeah.
Scala, yes, of course.
Of course, yeah.
So, Martin, on to your favorite subject as an Algol 68, or Algol in general, anyway.
Yeah, Algol 68 is the only one I'm familiar with, not its predecessor. Anyway, Algol standing for algorithmic language.
Yes.
Okay, for the hipsters amongst us that are not aware of this. Yeah, so Algol 68 was the successor to Algol 60, right? So
correct. Also running on mainframes at the time, I might add.
Yes, but you can still get a Algol interpreter these days running on Windows if you're interested.
Absolutely.
And on Linux to be
but
fair.
What's Windows?
It's an operating system.
Is it? Okay. Fair enough. Do continue, please, Mr. Wizard.
When was the last time you used Windows?
Let me check my records.
Okay, yeah, just checking. Curious fact. Anyway, yeah, so it was a very standards-based language of pages and pages of the stuff that
nobody cares.
Well, there was a lot of complaints about it at the time, and a certain guy was so upset with it all that he decided to make his own language, which was the opposite of Algol. I think, was he German? I don't know. I think he was German.
Who are you referring to?
Wirth, whatever his name is.
No, actually, he's Swiss. Or Swiss. He was Swiss.
Okay, fair enough.
Nicholas Wirth, you're talking about.
Yes. So yeah, he.
So what did Mr. Wirth do then?
Oh, he created Pascal, right?
He did many other things too.
Probably. But yeah, that was his main. In relation to Algol, that was his contribution to leave the project and start Pascal.
Yes. Any particular feature or trait that the Algol family of languages is known for, or is famous for? Sorry.
There's quite a few. I mean, the nice thing about it is, well, there's a lot of nice things about it actually. One is that you can use a proper begin and ends rather than squiggles and all that kind of nonsense, which become completely unreadable. So that's yeah.
So great language for people who like to type. Okay, I get it.
Well, okay. So languages aren't just for people who type, right? Okay, let's get this right. So just developing a program isn't the only purpose of programming. All right. Well, we can. That's okay. Why don't we extend this to the standards of programming that people may or may not have?
Very good. Very, very good observation, Martin. So let's start with the classification, shall we? So Algol is known for, similar to Fortran and COBOL, for its imperative paradigm. Care to elaborate, or should I do this? I'm happy either way.
Oh, why don't you do this one?
Imperative programming languages basically means you tell the compiler what to do and what way to do it, and the way to do it. In terms of, there's no deduction from the compiler side, unlike, for example, Prolog. It's a basic construct, as in it understands blocks. What's the word I'm looking for? Components, compounds. Compounds, is that the word? So essentially, I think it's one of the lowest levels of abstraction you'll find in programming languages. Like, for example, you can define functions, you can define procedures, but in contrast to other paradigms like object orientation, all the rest of it, you have to do pretty much everything yourself, hence the name.
Correct.
Whereas, for example, object-oriented programming languages know how to do polymorphism and encapsulation and so forth. These imperative languages normally don't.
Yep. Okay. No, I was never a fan of object-oriented programming, I have to say. Hence.
We cover that in a minute.
Okay. Cool.
Okay. So Algol, COBOL, and Fortran, I reckon, would be kind of the three initial examples for imperative languages. And I'm talking about the original languages, not necessarily the add-ons that came later. Of course, you can get object-oriented flavors of both Fortran and COBOL these days. Whether people use them is, of course, a different story. And what is also important, yes, Nicholas Wirth is famous for two languages, Pascal, namely Pascal, and something called Modular 2, which most people, I reckon, consider as the successor to Pascal. Both languages, not necessarily were the first ones, but both languages introduced the notion of structured programming. Because, for example, especially Modular 2, and the hint is in the name, you could, at that stage, and we're talking late 60s, early 70s with Pascal at least. Modular, I think it's in the 70s. Modular 2 allowed you to break down an application into modules, which in turn consisted of procedures and functions. And these set procedures and functions in terms of consisted of stuff you would normally find in your imperative language. Like loops, if-then-else clause, and all the rest of it. But the idea behind Modular 2 especially was to introduce modules like libraries and packages and stuff that you were then able to use to compose, and this is now the hint, to reuse algorithms.
Yeah. I can't think of any successors from Modular 2, can you?
No, not as far as I know. I mean, all of these languages were highly influential of what came later, like object-oriented language and all and all the rest of them. I mean, reuse is essential. Is one of the essential notions behind object-oriented programming languages.
I disagree with that. I mean, reuse is essential to any programming language. I mean, as long as you have procedure and functions, whether you split it into packages or modules, fine. But reuse is reuse, right? So that's, I mean, object-oriented paradigm, or whatever you want to call it, is, to me, it's a bit of a let's have an object and think of all the methods that you can perform on it, rather than just writing it.
Okay, progressing further, what differentiates an object-oriented language from a structured programming language approach? Like the difference between Modular 2 and, say, Smalltalk.
Smalltalk, oh my god, that was
Smalltalk is
the only time I ever used that was at university.
This is basically what happens if you fall in with the wrong crowd, Martin.
Did anybody actually use this in real life?
Oh, absolutely.
Okay.
You find links in the show notes, but Smalltalk about 30 years ago, make that 40 years ago, was really en vogue. Quite a few large code systems, and as I said, you find the link in the show notes, but there was, I can't even remember. But at the time, I came across some large code bases that were written in Smalltalk.
Okay.
And Smalltalk being, of course, one of the first object-oriented languages developed at something called, I think, PARC, right? As an Xerox Palo Alto Research Center.
Ah, I just remember it from university.
Yes!
Being a very annoying piece of part of the study that one had.
No, I mean, what are the general notions behind object-oriented languages in comparison to other languages, Martin? Any guesses?
Well, the object defines the methods. I think that's probably the. Yeah, that's how I would describe it.
Well, yes and no. First of all, you have classes. Classes define different levels of abstractions.
Yeah,
languages
like a hierarchy of okay.
Yes, this is the important bit. And languages like Java take this one step further, because the original Smalltalk implementation didn't allow, for example, to define something called interfaces, whereas most modern object-oriented languages basically define interfaces or abstract base classes like C++, Java, and all the rest of them. The idea behind the initial object-oriented paradigm was to provide a generic class and then derive more specialized behavior in so-called derived classes.
Mm-hmm.
In example, you have a generic class called fruit, and classes deriving from this basic from this generic base classes like apple, like banana, different shapes, different form.
Other fruits are available. Yeah.
Other fruits are available too, exactly. Or different
Cherry.
Example, yes. Or another example would be a vehicle, right? You have a generic base class called vehicle, essentially defining methods or member functions as they're known in C++, like start, stop, drive, steer, that sort of thing. And then derived classes like car, boat, plane would implement these functions in a different way.
Mm-hmm.
Because planes, for example, planes do have wheels, but boats normally don't. So to steer a boat or to accelerate or slow down a boat would be quite different from doing that with a car. So the idea is to provide different levels of abstraction through derived classes.
Mm-hmm.
And needless to say, the idea behind the general approach was to increase the level of reuse. So, for example, if you have, and the idea was also to encapsulate certain common behavior in set base classes, and only to implement the differences in the derived classes, so that you actually, if you want to introduce a third vehicle like a bicycle, you would only have to implement the stuff that is not already present in the base class.
Yep. Exactly my point. Yeah.
And of course, Smalltalk was one of the first languages that introduced something like a meta level.
You creating all these levels of abstract
yes.
for 3 items. It's just a complete mess.
But of course, by going directly from structured programming languages to object-oriented programming languages, we skip one important step of the evolution, right? Namely function languages. First example that entered the stage of a functional programming language? Anything that comes to mind?
There's loads of them, right?
Which was the first one?
The first one? I don't know, I'm not that old.
You said boldly lying? Martin, do you know just checking, do you know an operating system called Emacs?
No.
You don't?
No.
I'm sure you've come across it. It normally comes in the disguise of an editor, but
Indeed.
at the very core, it's an operating system. And that is, funny enough, that is actually written in Lisp.
Okay.
Lisp goes back to also late 60s, early 70s, when people had this idea of constructing a computer, including software, that was able to simulate a human brain in terms of something called artificial, in brackets, intelligence. Because Lisp was one of the first languages to implement AI software. And as I said, you're talking MIT, you're talking 70s here. And functional programming languages introduced something like, for example, anonymous functions like lambdas. Everything more or less.
No. They already had that in alcohol already, lambdas.
Did they?
Mm-hmm.
Well, going back, actually, they did have them plan calcul, but
probably. Yeah.
No, I mean, Lisp was actually. Any idea what Lisp stands for?
We need someone older on the show that can talk about the
Martin, any idea what Lisp stands for?
It's
the acronym.
Not speaking with a limp, you mean? Oh.
No, exactly. No, it stands actually for something called Lisp processor. And that's exactly the idea, the initial idea behind it, because the most fundamental data structure in Lisp was actually a list.
Okay.
As in, you had a head of a list, and then you had a tail of the list. Like a recursive structure.
What if you don't have a list?
You have something called an atom.
Okay. What if you have a set?
You can implement that as a list. You just have to make sure that items don't repeat that list entries do not repeat themselves. because there are no such things as two identical items in a list, right? In a set.
Yeah, but then it's a set. So, anyway, okay. So, fine. Yes, okay. A list-based language.
And that was Lisp, yes. And these are still used today because Emacs, as we all know, is one of the most popular editors that are around, I suppose, especially with old school people like me.
That's a good question.
Martin, of course, prefers Vim for some reason. I don't know why, but
No, BI.
yeah, sorry. Yes.
None of this modern
Vim, exactly. Vim would be way too hipster for him. Okay, what came after object-oriented languages, Martin? Nothing much.
Oh,
right?
there's still around quite a lot object-oriented languages, aren't they not?
Java, Kotlin, Scala, Julia. That's it, I think, for the recent editions, because Go, Lang, Rust would at best considered to be abstract data type supporting languages. I think the Rust people are working on object orientation, but I'm not too sure what the exact status at the very moment is. But version 43, 42 at best supported abstract data types, like the original Rust definition.
Yeah, well, anyway, so after the generation of Pascals and what have you, came the fourth generation languages.
But they are dead, right?
Unfortunately so, yes. They were... Well, no, SQL isn't dead.
You say that! Full disclosure, people, Martin is a believer in something called Postgres.
I think there's quite a few people that use it around the world.
I'm not saying you're the only one, Martin. I'm just saying. Yes, SQL being
a
one of
proper
the
database, unlike some in-memory nonsense.
SQL, of course, would be the example, with the exception that proves that point that actually most of the fourth generation languages are pretty much dead. Do you have any example of a fourth generation language that is still used in production apart from SQL?
That's a good question. Does ABAP still exist, or did they change that?
Well, actually, you have a point, because I think it's still around. But would that be a true fourth generation language?
I think it's classed as a fourth.
For the hipsters listening to this podcast, ABAP of course would be ABAP of course would be a programming language invented by a company called SAP in the 70s, if I'm not completely mistaken, as in the first language that SAP used to implement their functionality in terms of ERP and CRM, all the rest of it. Mm-hmm. Funny enough, they made the move to Java late 90s, I think.
Did they? Okay.
Yes. When they invented something called there's an enterprise bus in SAP. It's not NetBeans, it's something else. You find the links in the show notes, essentially, and that was the first Java implementation that they used to essentially facilitate communication between the different components of an SAP system. Okay. NetWeaver, that's it. NetWeaver, yeah. NetWeaver was their answer to proper enterprise service bus as an ESB. And that was invented, I think, late 90s for that reason. Because as we all know, SAP systems are not normally used in corner shops, but rather in enterprises beyond a certain size. Because only they have the funds at their disposal to finance SAP projects.
Yep.
But apart from ABAP and SQL, there's nothing that comes to mind in terms of a fourth generation language that has survived.
No, lesser known fifth generation. Yeah, indeed.
What's fifth generation then?
Well, the one that comes after 4.
Fair enough. Any examples, Martin?
I think there were 2 attempts at it, but still not quite. It was mainly the idea was that became self-generating code, right? But Hasn't quite happened yet.
No. So what came afterwards? Nothing much new, right?
Well, people keep reinventing the same things.
That's exactly it.
Some do a better job than others, I have to say. But, yeah.
So with that, we'd like to conclude this episode. Thanks for listening, people.
No, seriously. I mean, if you're studying, I don't know, computer science or whatever it is, or any, even in secondary school, I think they are shoving Python at everybody, right? And there's nothing. It makes more sense to start with something closer to how what's closer to assembler, right? In my opinion. So,
okay, I mean, Python is probably a good example because it started out pretty much like an object-oriented language, and it had lambdas from the very day one. But over the last 30 years, that language has just been refining things, because Python as such, whether it's 2 or 3, and most people probably will shoot me for it, but if you take a very close look at the core, Python did not bring anything striking new to the table, because all of these concepts were pretty much known already. In the language, they have been around for decades. By the way, same goes for Rust and Java.
Exactly. Yeah. So yes, it's curious why these events keep repeating itself, but then.
And people invent new languages all the time, right? I mean, Rust has been around for the last 10 years, 11 years.
Okay.
Julia is 7 years old, 5 years old, something like this.
Yeah, something similar.
Kotlin is around the same age. Scala probably. Yeah, Golang goes back to 2007, if I'm completely mistaken. Maybe earlier than that.
Right.
But again, from an innovation perspective, what does Golang bring to the table? Okay, further increased parallelism, all the rest of it, but you had that before. Occam, for example, rings a bell, right? Occam was long dead now. It was, I think, invented in the 80s, and Occam was actually the answer to the increased requirement for parallelism at the time. But nobody uses Occam anymore. So again, it's not something new. Same goes for Rust. If you take a look at the multiprocessing facilities that Rust provides, yes, Golang is not too far away, and other languages come very close too. So there's no real innovation there. Of course, this is a very provocative statement. If you have different opinions, please send feedback to feedback@linuxinlaws.eu.
Yeah. No, it's interesting. What do you need from a language, right? It's probably the question to.
I mean, at the end of the day, languages are like cars, right?
It's probably different
cars get you from A to B, right? Programming languages basically abstract from the operating system. Use programming languages in order to avoid having to implement your algorithm in assembler. Yeah. Which is the basic common denominator that most computers understand directly, because this is the way they work. Unless you're going for microcontrollers or transmuters or TensorFlow processing units, because these would be specialized things, or even just basic GPUs, right? So, but at the end of the day, if I'm talking about any major CPU architecture like CISC ones, like Intel, like RISC ones, like ARM or RISC-V or whatever, they can all understand assembler. Not a big deal. C comes pretty close to assembler, but other programming languages offer more abstraction layers. I mean, this is it's probably I mean, C is probably a good example for the case where people still prefer to be very close to the machine, because at the very end of the day, C is kind of close to the hardware level. It doesn't provide a lot of instruction, but if you take a look at the code base that is out there on places like GitHub and so forth, or just take the Linux operating system kernel, it's written in C for a reason. That code base is now about 30 years old. And if you take a look at many of the frameworks like GTK, like Qt, they are all written in C.
Yeah, and there's a lot of major projects that are also written in C, like Redis, Postgres. It's as you say, closer to the hardware, the better.
Plus the fact that you get a very rich ecosystem for C. Other programming languages like Python, Rust, and Golang are catching on.
Yeah.
But the fact is also that the compilers have matured for the last at least 20 to 30 years. At that time, Golang or even Rust wasn't even invented.
Yep. Okay, so what do you look for in a programming language?
Good question. Probably learning curve, as in how quickly I can learn a programming language. Never mind the paradigm, because as I said, there haven't been any fundamentally new paradigms around for the last at least 20 years, if not longer. The ecosystem, the availability of suitable compiler suites on any given platform, and what people have been doing for that program language, and needless to say, how that program language interface to other things. There are two common denominators around: C bindings and, of course, for a foreign function interface. So if a program language doesn't support this, it's probably not for me, because you'll always find a borderline case that where you cannot get an existing implementation for, at that case you either have the choice to write it yourself, or to have to incorporate a different program language. And early examples for integration approaches like the JNI, the Java Native Interface, go directly down that route, because when Java was invented, like mid-90s, there was an awful lot of code already existing that was written in C. So the Java people made one smart move to provide an interface that would allow Java programs running on a JVM as a Java Virtual Machine to use that C code base, with all the disadvantages that approach had, like not unmanaged code rather, missing memory safety and all the rest of it.
Yeah. Okay. No, that's.
So, Martin, what are you looking for in a programming language?
Most of those things. One of the main things is readability, I think. Easy to learn, goes hand in hand with that. Interfacing to other. I don't personally need that as much as you do. Not programming any devices as such. So I'm happy with that. But yeah, the ecosystems available, libraries, etc. Because this is all about reuse again, right? Why write something if someone else has already done it?
That's exactly it. I mean, at the end of the day, programming languages are like cars. Because if I say women, I will get shot, so I won't say women.
I think neither of those are great comments.
Let me elaborate on the car angle here. All the cars, especially if they're working as in functioning, take you from A to B. Some cars are faster than others. Some cars can pack more payload than others. Some cars are easier to drive than others. And that's exactly true with programming language. Basically, it depends on the use case. If I have a challenge at hand, I normally take a look at what's out there already. And then non-functional requirements come into play, like how fast has the generated code to be in order to meet the performance requirements that the particular use case at hand demands, that sort of thing. For example, if I'm looking for sub-millisecond latency on a given CPU architecture, I can normally safely rule out interpreter-based programming languages like JavaScript, Python, or, what's another good example, Lisp, for that matter.
Yes and no. I mean, there's obviously C interpreters for Python and Scythe and friends. So
if you can live with the drawbacks that these approaches brings to the table, yes, of course.
Yeah, no, it depends, as you say, what the use is. If you are programming a low latency device, then yes, that makes sense. If you are doing a project that doesn't have such requirements, then you go for the easier approach.
Absolutely. It
Okay.
all depends, people.
Yes. So maybe we should start our own programming language.
Why?
Well, why not? So you can get a hipster following.
Any final farewell greetings to these hipsters, Martin, as you keep talking about them?
Well, I don't know. I don't. Yeah.
You don't know any hipsters, okay?
I haven't been to California for a while.
They don't live in the UK, no?
No. They have to live in yeah, we don't have. Mind you, we do have coffee shops as well, but.
Especially that you also have coffee shops in the Netherlands, right?
I believe so. We do drink coffee. Yeah, Douwe Egberts is well a long-established coffee brand.
Yes, very good. Okay, any final remarks before we close off the show?
Yes, well, final remark is I think for the hipsters out there that haven't had the pleasure of programming in Algol 86, do check it out.
Wasn't that 68?
68.
Wasn't that 68?
That's what I said, yeah.
Okay. Maybe I'm old. Okay. Now that the famous episode on programming languages has finally come to its conclusion, it's time to cover the POCs. What's your POCs?
Well, we can't say it's famous yet because it hasn't gone out, but yes, it will be famous, I'm sure. Okay, so my POCs of the week is a book, again, because I do like books. Not that I have time to read them, but they're quite useful for many things, which is called Cracking Codes with Python.
Ah, finally! You intend to learn Python once again?
No. It's just a bit of a hobby.
You just want to crack codes. That's okay.
Yeah, this is a long time since I learned anything properly, I have to say.
Especially Python.
Yes. Well, this is the beauty about Python. You don't have to learn it.
You don't? Okay.
No, it's great. It just writes itself.
Just works. Excellent. Okay.
What is your POCs of the week then, Chris?
I don't have any, but before we go to my petty anti-POCs, why don't you elaborate a little bit on that book?
Okay. Right. So this is a, well, as the title says, are you interested in cracking any codes? Well, obviously there are many different coding algorithms, as in algorithms to create codes. And should you have powerful GPUs at your disposal, then this comes in quite handy to calculate various things you might want to find out.
So cracking code means like a brute force attack, like password cracking. Sort of thing?
Yeah, but then different.
And where do the GPUs feature?
They are installed in a machine called a computer.
Yes. I get that, Martin, but that book covers the unknown art of taking Python source code and translating that to something that the CUDA interface can understand so that the GPU can execute the code?
No. This is a theoretical book, right? So that is implementation.
I see. So why is it called Basic Cracking Code with Python?
Because it covers various coding algorithms that you can implement and decoding algorithms you can implement with Python.
Okay. I thought it wasn't about the implementation.
Not on the implementation on GPUs, indeed.
I'm sorry. Okay. I got lost, as I usually do.
I know, it's very confusing, isn't it?
It is indeed, Martin. It is indeed. Links in the show notes, of course, if I can find this book.
Do you need a proper computer with the GPU in it one day, maybe?
I do have proper computers with GPUs in them, yes.
A on-chip GPU.
I think I have one or two, yes, with a separate GPU built into the graphic card, yes.
Thank you.
Say again?
From which century, dare I ask?
Last one, I think.
Sure. All right.
Okay. Onto my antipox. Courier authentication team people, if you're listening, please do something about the debugging level. I ventured last weekend to tell my postfix instance to use the authentication team that comes with Courier to authenticate people when they want to send emails, and it took me way too long to properly get to the bottom of the issues that I was facing because of the debugging information that the authentication team didn't provide. As a matter of fact, eventually I had to resort to strace to see what was going on the system call level. And that's not something you should have to do. No. There was a recent episode on this one, yes, but it may come as a surprise to you or shocking news, rather, Martin, that strace and myself have been friends for at least the last 20 years. So
only 20. Interesting. Yeah,
it came in handy. So I'm Korea people, if you're listening, get in touch and I give you some hints of how to do it better. Or I may even submit a pull request at some stage. And with that, we are almost at something called the feedback.
What do you mean almost? Why almost? We are at the feedback, aren't we?
We are at the feedback, yes. Indeed, we are.
Okay, that's right. I thought I missed something.
And if
feedback.
I can find it, yes, feedback.
S01E24 feedback.
And yes, feedback. A guy called, not a guy, but rather one of the HPR hosts by the name of Operator comments on the second last show.
Episode 21, yes.
Episode 21, yes, thank you, Ron. Greetings and great show. And the rest it's technical details like, we got kernels that are like a terabyte and all the rest of it. He also just discovered NetHawks in Linux. And of course, he's a big Tmux fan, as in the terminal multiplexer. But then people who isn't, right? Who is beyond the 25 years of age stage. And of course, he sent that email to something called feedback@linuxinlaws.eu. And people, if you have feedback, please. No, sorry. Of course, you're right. He posted it on Hacker Public Radio. My mistake, Operator. I do apologize. Yes, he posted it on Hacker Public Radio, and he could have sent this to feedback@linuxinlaws.eu. But both ways are welcome in terms of how to get in touch with us. And the email address is feedback@linuxinlaws.eu, but you can also, like Operator did, post a comment on the HPR website on the episode. And with that, we'd like to thank you for listening and keep on coding. Any final remarks from your side, Martin, before we close off the show?
Oh, sorry. No, keep on coding. Sounds good. Keep on commenting. Keep on feedbacking. Yes. Keep on listening. Excellent.
This is the Linux In-Laws.
You come for the knowledge,
but stay for the madness.
Thank you for listening.
This podcast is licensed under the latest version of the Creative Commons license, type Attribution Share Alike. Credits for the intro music go to Blue Sea Roosters for their song Solid Market, to Twin Flames for their piece called The Flow, used for the segment intros, and finally to Celestial Ground for their song Sweet Justice, used by the Dark Side. You find these and other ditties licensed under CC at Jamendo, a website dedicated to liberate the music industry from choking copyright legislation and other crap concepts.
You've been listening to Hacker Public Radio at hackerpublicradio.org. We are a community podcast network that releases shows every weekday, Monday through Friday. Today's show, like all our shows, was contributed by an HPR listener like yourself. If you ever thought of recording a podcast, then click on our contribute link to find out how easy it really is. Hacker Public Radio was founded by the Digital Dog Pound and the Infonomicon Computer Club and is part of the binary revolution at binrev.com. If you have comments on today's show, please email the host directly, leave a comment on the website, or record a follow-up episode yourself. Unless otherwise stated, today's show is released under a Creative Commons Attribution Share Alike 3.0 license.